feel free to get pizzas. There should be plenty tonight. There's some brownies too and drinks and stuff. So help yourself. And tonight we're very happy to have Billy Korando from Oracle, to talk about to Java. I still use that N, but it means 26.
Yeah, I meant
right?
just about, yeah, 20.
That's right. Yeah, thank you. So, okay. So we're just going to step through just some quick kind of, well, I guess I don't do it right order. Okay, let me just do some quick housekeeping first. So important announcement, although I already made it a while back, we switched to using Luma. I think I'm seeing more folks starting to use Luma. So if you know of friends and colleagues that are looking for a Java users group, please use Luma. Because we still are on meetup.com, but just for now, we have a notice to tell people to switch to using Luma. So thank you for doing that. And if you're interested in entering in our raffle, and we get 2 complimentary licenses from JetBrains, and you can activate it for any of their products. And most likely for Java users, we use IntelliJ, but you can activate it for anything. But in any event, we get 2 raffles to raffle off today. So if you're interested, please scan the QR code or go to the bit.ly link to sign up for that. And then at the end, we'll do the raffle. So, but also just to reminder, if you have won the license in the past 9 months or so, then you are not, or actually if you're winning it, more than or less than 9 months ago, you're not eligible. Yeah. And I think, Thomas, you have a question? Yeah. I can barely hear you. You can't hear me? Yeah. I don't think, oh, actually, that's true too. I forgot about this mic. Yeah. Okay. Because I only have the mic for the video, for the stream, and I forgot about this. Thank you. Hello? Can you hear better now? Thank you. Okay, thank you. Sorry. Okay, if you miss anything earlier, let me know, I'll repeat too. But I assume that you're all good. Okay, so just some housekeeping again. Start using Luma, and also we have our Chicago Tech Slack. If you haven't already signed up for it, that's the link. And also the Java off heap. Freddie Gemay, the previous Java Users Group president from 2013 to 2018, he still doing the Java off heap podcast too. So if you're interested, please subscribe to that and listen to that. And we're on Mastodon, although Fediverse, it seems like for now it's not as popular. However, if you want to connect with us, we are on Fuji. And also I'm listing too for Chicago Kotlin Users Group too. They also have a presence on Mastodon. And then our Twitter is CJUG, that's our handle. And we are also on Discord. Now, for some of you, you may already be connected to Discord. If you get annoyed, and that's what I did, I happened that I'm finding recently there have been a string of new users sign up, and then they're just advertising themselves. They have all these skills looking for work. And I encourage people to share that, but then those people were getting a little unruly. And 2 nights or 3 nights ago, somebody sent out some weird images on all of the channels, and I caught it. I'm so glad. So I immediately banned those accounts. And now too, I also require people, when you sign up on the CJUG Discord, you will need to answer some questions, but very simple, just asking why do you want to join? And also, can you share your LinkedIn profile or GitHub repo? Because I don't want anybody randomly come in and trying to trash our server. So hopefully too, you are not, too annoyed by that. So, and also too, we have set up, every time we have set up a room, a Discord room for any kind of discussion about that particular meetup. So I've set up one is over here, I usually name it by date. So 2026, 0129 is Java and beyond. So, and if Billy wants to sign up for our Discord and answer questions too, maybe people can ask you more questions there. So that's that. And then community info, we are community partner of JetBrains. As mentioned, they are donating 2 raffles per month for raffling off. And there's also devitjobs.us if you're looking for jobs. Upcoming events. So our March event haven't been decided yet, but in May, it's pending right now. Confluent will be coming too. So it would be Kafka data streaming along those lines. So you can mark the calendar if you're interested in that. And other confirmed speakers, actually also from Oracle, from the developer advocate teams, Alina and Josie Pomal. But then still, we need to try to find a time. So still kind of in the process of figuring that out. And if you really are interested in an open mic event, meaning you can, on conference style, doing lightning talks, let me know. I like to organize that too. So if there are enough interest, we can do one. And conference info, some community information is about DevNexus. The conference is popular in Atlanta, Georgia, run by the Atlanta Java Users Group. It will be on May 4th to the 6th, and they are giving out a 50% JUG discount code. So if you're interested in going, it's DN26 Java. That's the code to use to get 50% off. And if you're interested in speaking at CJUG, you can submit your proposals to present at cjug.org. And for job seekers and recruiters, we are having this group, been up for a while. If you're interested, there are some recruiters. There used to be more, but let's see if they come back again too. The LinkedIn groups, this is the link to it. So if you're interested. And the next thing is we want to thank you for the event host, Microsoft Chicago. And I want to say thank you to David GR for booking the venue for us. And thank you. Yeah. And would you like to say a few words too? David is also running some meetup groups too, and Chicago Cloud Computing, right? One of which, yeah. So
Thank you, Eric.
thank you.
To my job. I want to call attention to the Chicago Cloud Computing User Group. We meet once a month in this room. Our next meeting is February 24th. Everyone on the board over there, go to chicagocloudug.com, and that will take you to the meetup site. And we ask you to please register so that you can get those little stickers we got today that let you build easily, and so that you order the right amount of food. Are there any questions?
Robert.
For those interested in Wi-Fi, we do have Wi-Fi.
Oh, yeah.
Just write down your email address on the back of a $100 bill. Somebody else probably wants this, so pass it down. Yeah. And that's all I have to say, except that that's going to be a really good time for everyone to silence their cell phones.
Oh, yeah.
Thanks.
Thank you. And thank you, David. And so too, I know David will say it later, is if before you leave tonight, if you can help to clean up your area before you leave, that will be very helpful. So, okay, so thank you again, David and Microsoft. Also, friends of CJUG, I want to mention too, the worldwide Java community is really big, as you know, it's all corners of the earth, essentially. But in particular, we have Atlanta JUG, Boston Java User ACM Chapter of New England, Garden State JUG of New Jersey, Kansas City JUG, Missouri, that's actually Billy's, and New York's Java SIG, the oldest Java users group in the US, I think also in the world, and then Pittsburgh JUG of Pennsylvania, Portland Java users group of Oregon, and Virtual Java users group. So they're still very active, so go to visit their site. Sometimes they have meetups that's virtual that you can join as well. And news. Java 26 soon to be launched, 3.17, very soon now, in just a month and a half or so. So stay tuned. You guys going to have a launch stream, right? Yeah. Yep. Okay, stay tuned. We'll be sharing that too with you. And now our very special speaker, Billy Korando, and he's a developer advocate at Oracle and a co-leader of the Kansas City Java Users Group. Very experienced in software engineering and consulting, and especially also in Java and Spring and more too. But I want to highlight that. And of course, he's a big fan, and I know we all know he's a fan favorite. Anyway, it's Kansas City Chief. So here it is. Yeah. The stage is yours, Billy. Thank you so much. Yeah.
Thank you.
Okay, thank you. Do you want to use this?
I'll be probably loud enough.
Yeah, you're probably loud. Okay. All right, great. Okay.
All right. Thank you, Mary, for that introduction. Are you able to hear me down there? Perfect. All right. Okay. Thank you for that introduction, and happy to be here. So we're going to talk about Java 26 and beyond. So I'm just going to quickly get asked, how many people here are at least on Java 17? Pretty much.
At least.
Wow, yeah. Glad to hear that. So that's been nice to see when I'm particularly giving this presentation, which I update about every 6 months because that's our 6 months release cadence, I asked this question. I remember about 2 years ago when I was asking this question, like it was most people, like about half or a little bit more than half, were saying Java 8. Then it seemed like about last year or so, it started really moving to Java 17, and it's really nice. So, like, how many people are on Java 21? A few. Java 25? No, no? Okay. So just Mary. Yeah. Cool. Well, either way, regardless of where you are, at least here on Java 17, there'll be something for you. We could always do a review, but that may just take a little too long. So, as mentioned, my name is Billy Korando. I am a Java developer advocate from a little company you might have heard of called Oracle, but don't hold that against me. I'm an okay person. I don't know. I don't want to say to my own too much here. So, important information. First, please ask questions. And also, I have 3 of these little Duke stuffy toys. So if you ask like a good substantive question, and you're one of the first 3 to do that, you can get a Duke stuffy toy or plushie. If you do have questions for later on, please feel free to reach out to me at billy.corando@oracle.com. I'll be happy to answer any questions you might have. And you can get a link to this presentation right here at the GitHub IO presentations to Java N and beyond. Of course, like I said, I update it about every 6 months, or fixing whatever little issues I might have with it. If you would like to know more, if you leave with an intense desire to know more after this presentation, we have a lot of great sites for you. So we have, yes. Yep. Oh, yeah, absolutely, for the link. Yep. Not quite yet. Yeah, I remember the first time I did that, someone's like, "Can I have a doll?" I'm like, "God dang it." So now I had to like stipulate. Are you good? Perfect. So yeah, if you leave with an intense desire to know more, we have a lot of great locations. So we have dev.java, along with having tutorials, and also we have the Java Playground, which is an in-browser tool that you can use for to test out new IDE features. So, or not IDE features, new language features. So if you don't necessarily want to have to download the latest one, maybe your system is locked down, you can go to dev.java and kind of test out some of these new language features I'll be covering here later in this presentation. Also, we have a community page where we have all the links to like all the different jugs around the world that we know about. Like I said, I think there's about 200 maybe or something like that. There's a lot. Like they're all over the place. There's our Java YouTube channel. So if you go to youtube.com/Java, that will be where we'll be live streaming when Java 26 is released here in about a month and a half, and then the Inside Java podcast. Also, on another conferences, Java 1 is we're coming back again this year. It's March 17th through 19th, so that obviously also lines up with the release of Java 26. We're in Redwood City, California, which is just in the Silicon Valley area. If you want more info, it's at java1.com. And also, if you use that discount code, you can get an extra $100 off. The early bird ticket pricing is ending here on February 9th. So if you're interested, you should definitely go and get your ticket now. But it was a great time. We kind of really truly brought it back as its own separate event last year, and it actually went really well. I was pretty nervous heading up to it. Of course, that's also just very common whenever it comes to running a conference. You always a bundle of nerves, but it ended up being a really great time. And it's also an opportunity for you to meet all of the JDK engineers behind the people who are actually designing and implementing the features that I'll be covering here in this presentation, who obviously know a little bit more or a lot more than I do about this stuff. All right, for the agenda, like I said, sounds like everyone's at least on Java 17, so we won't go through a review of 11 through 17 features. But yeah, we'll then start with like the new language features that have been added since JDK 17. After that, we'll get into the API updates, new runtime features, deprecation removals, and then we'll look a bit into what is coming beyond. All right, so new language features. So a very important theme for new Java language features is the addition of pattern matching. So the first time we did some pattern matching stuff, was that JDK 11? man, they all kind of blur together. But we added pattern matching, for instance, of a number of releases back. And then our next one was pattern matching for Switch. I remember when this was going through preview, I was really looking forward to when it was going to be added as a final feature, because it pairs really nicely with another feature that was released a bit earlier. But with pattern matching for Switch, when you're doing that, the pattern must be exhaustive. So even if you're writing your switch as a statement that is like there's not any sort of value that is coming back out of it, like if you're just printing out log statements, you would still have to cover all the possible programming paths when you're doing pattern matching. And we'll see what that means here in just a moment. You can also include a null case directly within the switch as well, which is also very nice for readability. So what does this all kind of look like? So here in this very simple example, I have an interface shape, and then I have three classes implementing that interface: triangle, circle, and square. So here with triangle, it doesn't match. It's like, okay, if shape is a type of triangle, then we also have the when guard clause where we can then do some interrogation into that matched value. So in this case, I'm just simply checking to see how large is the area of this triangle. So if it's over 100, I do some other little bit of behavior here. In this case, simply saying, oh, that's a large triangle. And then on anything else, well, that's obviously considered a small triangle if its area is below 100. But as you can see here, I'm just writing out system out print line, so that's just a statement, but I still need to include a default case here at the bottom to make this switch exhaustive. Also, the order of these does matter. So in this case, I could not flip around this case T when area is greater than 100. I can't put that after the triangle T one, just because the triangle T would dominate the following case. We kind of have that in many other areas in application or in Java, where following statements can't dominate the statement after it. There has to be some way to get to it. So that the order of that would matter. You can't just have them dominate it later after that. As mentioned, you can also handle null directly within the switch. So if for some reason the variable shape in my code could be null, instead of having to wrap this switch with an if statement and then checking if it's null, and of course obviously handling that when that happens, I can just include that directly within the switch itself. And again, the nice thing there is it just helps improve readability. I'm not, again, having to nest things down, having to wrap things in if statements. It can all just be kept within the switch. So what I was really interested in looking forward to when it came to pattern matching for Switch is how it pairs nicely with another somewhat new language feature, sealed hierarchies, which was added in JDK 17. So with a sealed hierarchy, what that allows you to do, in case you haven't really used them too much yet, is it allows you to define what classes can extend off of a class, or in this case with an interface, what classes can implement an interface. So in this case, because I'm defining these interfaces or these class implementations of triangle, circle, and square within the same class file, then the compiler automatically assumes that these are the only classes that can extend off of the shape interface. But so all the same, triangle, circle, and square are the only ones that can implement shape. And because I cover triangle, circle, and square in here, well, then that means that it's exhaustive. It's covering all possible coding paths. So I don't need to include a default case anymore. So there's two nice benefits to this. One, it's a good thing just because, a little bit less verbose and not having to write out a useless default case. How many times do we have to write out like some sort of, exception, even though like that exception can never be thrown? You're like, oh, I had to write this exception now, or I had to catch this exception. That's annoying. So it's good not to have to do that. The other benefit to that, though, is if we were to later come back and add another shape that we support, maybe we start supporting pentagons, hexagons, get really crazy with octagons, and so on. One of the easiest ways to introduce a bug is when you add a new feature and you don't go around and test all the areas of how that can be added. Just because, I'm a huge proponent of automated testing, but automated testing can very easily miss when you add something new because it doesn't know to check for it. So it could be very easy if I was, assuming that this wasn't all within the same code file. In one location, I added like a new shape that we support, and then I didn't go through and updated the switch, and then all of a sudden we have a bug in production. Because there's a no default case there, this would get a compiler error because it's no longer exhaustive. So like that prevents a bug from getting to production because you couldn't even build your code to get it to production. So I think that's one of the really nice ways that this stuff, some of these features, initially it's like, oh, okay, that's interesting, sealed hierarchies, but how some of these features can work together and support each other is very nice. Another feature is record patterns. Yes.
When you're inputting these guard statements
Uh-huh.
on the actual, is it going to evaluate the method lazily, or is it over towards pre-evaluate these methods whenever you
Reevaluate. What do you mean? Like, do you like check to make sure it's like a valid code, or check to? Uh-oh. Uh-huh.
to
When it actually match on it. Yeah, it would only do that when it actually matches on that case. Then it would go to the right side of that guard and then check to see if those statements are true then. Yep. Yep. These are just the pattern variables. So if like the case, if sealed I should change this to say here, but if sealed hierarchy is a type of triangle, then when it matches here, then it's setting that value of triangle to the T, and then I can reference that later in the case. Yes. Yes. Uh-huh. Uh-huh. Uh-huh.
here, is it going to keep that original T area value for the next case?
So that you bring up a really great point. So the way pattern matching works in Java is that it's what's called flow scoping. And so this T value is only set to wherever the compiler definitely knows it has been matched for. So in this case, even though I have this is T here twice within this, it's actually two distinct variable names with to the perspective of Java. So yeah, and then so it'll match here and it'd be like, oh, okay, this triangle is less than 100. So then it drops down to here. And then it would then supply this for this other T. So like it's two distinct variable names, which is also kind of nice. So that way you don't have to arbitrarily think of like different variable, you don't have to be like T1, T2, T3 if you have maybe a lot of checks for different, cases for a triangle or something like that. Does that make sense? Or does that answer your question? Or okay. All right. Great question. Oh, wait. I could see. Here's a question for you. And do you? Woo! See, fan of the Chiefs. Like that was like a very Patrick Mahomes throw, right? And I'll get to you. So yeah. Oh, then a null pointer exception would be thrown. So the reason you don't have to include null is because like the compiler, like it already knows how to handle a null pointer exception. So yeah. And then you had a question? Oh yeah. Yes. Yeah. I'll show you this specifically. So when you're doing that, when you're doing a sealed hierarchy, as I was doing there with an interface, you wouldn't have to declare it sealed, non-sealed, and things kind of like that because this is an interface. But here, if I was doing it as an actual class, so here we have user up here, and in this, I am giving the permits clause, and that's optional. So permits is the saying, okay, user, only the classes of admin, customer, and guests can extend off of user. And because I am defining admin, customer, and guests in a separate code file, I would need to use the permits clause to sit there and say, like, okay, these are the classes that can extend off of it. So then to your question of non-sealed, so because customer is extending off of user, that means I need to declare that class is either non-sealed, which basically means it's like a normal class, and anything else, any other class that extend off a customer itself, or I could say it's final, in which case obviously nothing can extend off of it, or I could declare something as sealed as well, in which case, in this case with admin, only normal admin and super admin are allowed to extend off of the admin class. And because I'm defining these classes within the same code file, I don't need to use that permits clause. Oh, sorry. So,
Let's say so, oh, excuse me in advance for the dumb question.
please, by means, for that. Yeah.
Static as well. Is that the same notion, or are those? You know what I'm thinking?
Yeah, no, that would be separate. So like static refers to the availability of a class within like specific runtimes. So like you have an instance class and that has to be within that specific instance, where static is availability to whatever is within that scope of it. It would have to. It would need to be static if it can only be referenced in a place that may be outside of an instance. So, like a static method can call an instance method, but yeah.
Yeah, now that I spoke that out loud, I see what you're saying. Thank you.
So I guess you guys kind of ask questions at the same time. Who wants? All right, there. Go. Oh, sorry. But is that clear then? Okay, yeah. Feel free. No, no. That's what I'm here for. I'm here for you to help learn. So by all means, I love when people ask questions. Right. So next thing is record patterns. This was also added in Java 21. And also forgot to mention this earlier when I was talking about switch patterns. So it was added in Java 21, and it was added with JEP 440. So what that stands for is JDK Enhancement Proposal. So if you go to openjdk.org/JEPs, this can show you all of the different JEPs that we're doing. So whenever there's a somewhat substantial change being made to the JDK, it goes through the JEP process. And we do that to help bring awareness to a change coming. It's not always addition. Sometimes we're taking stuff away from the JDK as well, which I'll get to a little bit later. But what's also really nice about this, so in this case, record patterns is 440. If I was to put in JEPs 440 up here, then this gives you a breakdown on that feature. So if you're really more interested in learning about record patterns, are also in this case maybe sealed classes. If I didn't give a good enough explanation, so the sealed classes is 409. So if you was to, that's not where I want to go. So if we go to 409, this can give you a very detailed breakdown of how like sealed classes work. So that can be very helpful. That way you can, take it in and learn it on your own time. Or if there's something that's like, oh, you know what, I really am interested in pattern matching for Switch and want to see like all the different edge cases that it can handle, this can be a good way to kind of learn a bit more about that. Just because otherwise, if I tried to go into this level of detail, we would be here until, Saturday morning. And I'm guessing no one wants to do that. One other thing I forgot to mention as well, and this can be really good. So like, let's say if you're on JDK 17 and you are planning on updating to JDK 21, one of the really nice things the JavaDoc team have continued to update and enhance the JavaDoc feature. And one of the things they've added is this ability to see what new features have been added within a specific version of the JDK. So again, if you're going from JDK 17 to 21 or 21 to 25, you can come here, you can go to the docs API into the new list, and then you can actually then select to say like, oh, okay, what new feature, what other new, maybe more minor features have been added between these two releases. Similar is there's also the deprecated page, which can also be very important when you're doing upgrading to be like, okay, what new, what methods, what classes, and so on might be deprecated or getting removed here as we're migrating, something to keep in mind as we're going through the updating process. All right, record patterns. As promised, we're continuing on. So records, that was added back in JDK 16. And so records allow you to easily define a data carrier. So here we can see we're defining a record, a simple name record, or first name, middle name, and last name. It's a good way of being able to carry or to define a data class, and then also you can read it or very easily. So also oftentimes though, when you define an instance of class, you will also often want to get information out of it. So with record patterns, they basically allow for a deconstruction of an instance. And so in this case, this instance of this variable of O, which is not really a great variable name, if it matches with name, then I can just also quickly using reference the various components to the various fields within that name record. And so the way this works is that when you use a record pattern, it needs to match by position to a valid variable type. So in this case, I'm using the local variable type inference, or var, so that will automatically match it to string. But otherwise, I could also just use string here to match to it. But if I try to use some sort of invalid reference type, like I try to put like an integer there or a big number or something like that, that would be giving me a compiler error because that wouldn't be a valid type. You can all, yes.
When you say phones and instance, phone stuff is an object, right?
Yeah.
So let's say that already has all the variables. Can't you just print all right that or say 0 4 then 4
You could do that. Yes. You can also combine record patterns with switch as well. So just doing exactly that here. If case is matching, if name is a type of the name record, then I can get it here. And then I can also check to say like, okay, if record, when it's not empty, when the middle name isn't empty, then I will print out the name, a person's name one way. If it is empty, then I'll print it out another way, like the standard last name, comma, first name, and so on. So that was added in Java 21. One issue kind of with it though is, and it can be a bit better seen, is if you're using a non-trivially simple record, if you actually had like a data aggregate, in this case, like a customer class, which is made up of like a name, an address, a billing, and we can see like billing has like an address and credit card number and expiration date. There's a number of different fields here, and even this example is obviously, very simplified just for, comprehensibility here. But if we go down here into customer, and let's just say we want to do something with just the billing address. It's like, okay, if this is like a customer, all right, we are wanting to update their billing address, I'm still having to define all of these other variables, and that's not good. That's a bit confusing to look at. You're wondering why all these other variables are defined and never used. So we added the unnamed keyword or key value, where if you put that with an underscore, then then it's just a way of saying like ignore that value, so you don't have to actually define a variable name for it. So there isn't a runtime benefit for this. So if we were to debug this code, then the JVM would be assigning like a random name or a random name to these, so like these values here. So it's not like there's any sort of like you're saving memory or you're doing some sort of security by having this value not be available. It's all still there on the heap in runtime. It's just a pure syntactic benefit, but it's again very helpful because now whether it's yourself going back into this code 6 months from now or some future developer looking at this code years from now, it can be it's obviously it's eminently clear like, okay, this code is only dealing with the billing address or whatever it might be. You're not having to say like, hey, the only thing we care about, like in code comments, like the only thing we care about here is billing address. Don't worry about these other variables that we're defining but never referencing. And the other benefit is like, let's just say I need to do something just with the name record. I don't have to explode out those other records. So like it can really maybe shrink the code in some locations depending on how you're using it. There's also, you can also do it for unnamed variables. So like for example, in this for loop, I'm never actually referencing the n name in it. So I can just replace that with an underscore. A bit more of a practical example, you can also do with exceptions. Sometimes there's some exceptions, like in this case, like a legal argument exception. Sometimes you will be throwing that as like a client input exception, in which case you may not necessarily want to log that exception stack trace. And so I know definitely plenty of times where it's just like, okay, you're just kind of like eating that exception or you're printing out some sort of message, but you never do anything to the exception. In this case, you can also replace that with a underscore as well, just to make it clear that like it was a conscious decision to not actually do anything with that exception. All right, so continuing on for other new language features is stream gatherers. These were added in JDK 24 with JEP 485. And so what stream gatherers are, they add basically kind of like, it's like a collect, which is a terminal operation, but allowing that to be an intermediate operation. It allows you as the user to have a lot of flexibility on how to transform what's going on with the stream. You can have, many going into a gatherer and then one going out, or one going in and many going out, many to many, one to one. It just gives you a lot of flexibility rather than having to do a collect and then creating a new stream. So in this case, I am doing a list of names, actually a number of names I'm sure Mary would actually recognize on there. These are other fellow speakers. So I just decided to use them as a simple example for a number of different names. But yeah, in this case, I am using like a fixed window gatherer, which will just take 4 elements and put it into like one list. And I'm telling it to only do it 3 times. So I just take, we're going to take 4 groups of speakers and put them into groups of, or we're going to take groups of 4 speakers and put them into different 3 groups. But yeah, there's a lot of different options available. In this case, I'm doing like another gatherer, which is just looking for how many characters are in a person's name. So they have like 4 built-in gatherers, but you can also extend the gatherer interface to create a gatherer that does whatever specific business function you need to do. Because of course, like this, the base gatherers probably aren't going to fully cover every particular use case or business use case you might be dealing with. But yeah, you can implement the gatherer and then implement the behavior, all the different methods to implement the specific behavior that you're looking for. You can also further extend some of the gatherers just to add some additional behavior to them as well. If one gatherer is pretty close, but you just need to kind of change up the behavior a little bit to get it to exactly what you need it to do. Next is flexible constructor bodies. And what flexible constructor bodies allow you to do is allows you to do statements before the call to super within a constructor. So here we have 2 classes, person and employee. In person, among other fields, we have the age field. And when we call to create a new instance of person, we will check to make sure age is not below 0, because obviously a person's age you can't have negative age for obvious reasons. So if that happens, then we throw an illegal argument exception. So obviously that prevents this person instance from being created. Okay, but then we have employee. Employee extends off a person, but we're going to have a slightly different criteria for what's considered a valid employee. An employee must be between 18 and 65 years old. Now, before the addition of flexible constructor bodies, how we would handle that is a bit messy. So like we would have to make a call to super first. So we're potentially doing some unnecessary work because maybe this employee could be, 12 years old. Well, obviously, that breaks a lot of laws. So they're not going to become an employee there. So you're potentially doing some unnecessary work. Now, one way of handling that is to create like a static method and then call that static method within the body to super, to do that validation. But if you have like a non-trivial class, like if employee has like dozens of different fields with it, that can start to look pretty messy to have to maybe call a bunch of different static validators. So simply put, what flexible constructor bodies allows you to do is just to have some statements be before super. So in this case, we're checking to make sure age is within a valid range for our employee class, but you can also set default values yes, you can set default values as well before I call it a super. So that way it just works a bit better. One of the things I really like about this though, so like here we have, again, like another simple class hierarchy of obviously object, which all Java classes extend from. Then we have class A, class B extends off class A, class C extends off of class B. So one of the weird things with how constructors would work before is, in effect, the first constructor to be called would be the most super, the most the top class within the hierarchy, and that works a little bit in reverse from how a lot of this stuff works. Like if you have like a properties file, like you may have like a global properties file, but then that would be overwritten by like a more local properties file, and that probably would even be overwritten if you were to pass in values through the command line. So, but how this would work is like, okay, the most senior would kind of in some ways override it all. So, because you would first call this object constructor, then class A constructor, then class B constructor, then class C constructor. Now with flexible constructor bodies, if you did have some sort of setup in class A after the call to object, and then you had some maybe other finish up, now this would properly telescope that the prologue to class C, the most local class, is called first, then the prologue to class B is called after that, then the prologue to class A, then we get to the most senior class of object, and then we do whatever epilogue if you have in there after that. So to me, I just think it allows this call hierarchy to telescope in a reasonable way, in a way that you think it should work, that the most local gets called before going further away. Compact source files and instance main methods. This is another change I was really looking forward to. It went through a number of iterations before this. So at some point, we all have written the Hello World class, and there's a lot going on here. If you've never written any code before, not just Java, but like you're just a complete new student in like high school or something and learning programming, like there's a lot being thrown at you. You have access modifiers, class, static, return types, and void, method arguments. There's a lot going on here. So of course, how teachers would teach Java is they'd be like, hey, you know what? Don't worry about that. Just focus on the system out print line. You'll first do hello world, then you will change it up and pass in variables and go from there. But it's not a great way to learn to be like, hey, here's your first program. Ignore 80% of it and we'll just focus on one. You would want to, if you're learning something, be able to introduce concepts as you need them. So that way people can kind of learn the entire thing all at once and then build from there. It kind of reminds me of, so Mary and I, we used to be colleagues at a little company, another little company called IBM. And when the pandemic happened, um, we were all at home, and one of the things I was kind of working on was like, okay, I'm going to put together like a series of blog articles on like how to build and deploy like a simple application to Kubernetes. Because at the time I was doing stuff with Kubernetes, and like I find the documentation to be really frustrating. Like to say it's like, oh, how do you set up a health check? Okay, like it shows you like the 2 lines of YAML to do that, but it doesn't show you any of the other context. So like it was just so hard to understand like what's a complete explanation for this. And I also thought about that then with like Hello World, that there's a whole lot going on here. And if you wanted to explain it all, it would take a lot of time, which is obviously a very bad way to learn. And of course, like if you're a high school student, just your eyes would glaze over. So to bring Java, to bring the most basic of Java programs more in line with other language platforms like Python or JavaScript, we allowed creations of instance main methods where you can have hello world as simple as void main io println hello world. So, and then from there you can also do other instance methods. So like I could add like another method within this unnamed class that says add like or combine something together. So that way, if you're a new student learning, you can be like, okay, we called hello world, but then we can call other methods, and then you can maybe eventually add classes and stuff like that. So you can add these new things, new elements as you need them, and not have it all be forced to you at the very start. We also, within this IO class, added the read line method as well for reading in input from the console, because like reading in input from the console was just kind of weird and difficult before that with Java. So it's kind of nice just to have IO read line to just take in input. Kind of related to this as well, we also added module import declarations. So modules, every Java developer's favorite new feature that was added in JDK 9. Who was really happy when modules were added in JDK 9? Any hands? Any? No? Okay, well, maybe we'll convert a few people eventually. So module import declarations, what it allows you to do is kind of like how we have like the import star declaration to just say like, hey, bring in all the classes from this package. This just works at the module level where you can do, so like here I'm doing something with the HTTP client, and so I'm having to import like multiple classes from java.net to HTTP. I can just simply replace that with import module java.net.http. So this can be nice for, again, students who may not be yet that familiar with the package structure and the class structure of the JDK, that they can just have like a couple of high-level imports they can put up there and then not have to necessarily worry about that, like, oh, wait, where's our array list? Yes, go ahead.
Is there simply tracking on top of existing constructs in the JVM, or are they adding something new, like let's say it's this mechanism?
Yeah. Yeah, no, it is actually new features, because like, there be, if you try to write void main, in JDK 24 and before that without enabling preview, like, that would never work. So like it was adding new features. And I guess also somewhat with that is, if like, let's say you wrote two main methods, like public setting void main and void main, like there's also like an order of precedence in how this is called. So like public setting void main, because that's the existing behavior, is like preferred and called first versus any other main method. But yeah, so we can also then combine that down into the import module. And one other thing is that what's also nice about this is, between like this import module and our module import and the compact source files, is that it's also making Java a bit more of an attractive language to write scripting in. Back in my college days, like I got pretty familiar with Bash, but then I just kind of progressively lost all of my Bash scripting abilities over time. So it's kind of nice, instead of having me to go back and relearn Bash, I could just use Java to maybe write some sort of simple scripting file to like parsing a file or reading through a directory instead of having to go through necessarily use Bash or something like that again. Anyways, those two features and some others, it's all part of the paving the on-ramp. And Brian Getz is the chief language architect for Java. He wrote a article that kind of laid out the vision behind these feature changes, which was all the way back in September 2022. How time flies. Just a little bit of wrap up on the language changes. So a lot of these changes, it's heading toward the story of introducing data-oriented programming within Java, which, of course, there's object-oriented programming, function programming, or functional programming. Data-oriented programming, as its name implies, it has it to where you're working with data constructs, and that's kind of like the central element of records. So a lot of these features that we've been adding, and some more features coming, are all going towards allowing that vision to be done. And so a couple of years ago, one of my colleagues, Nikolai Parlog, he put together a really nice 7 or 8 part series that kind of goes through these different elements of implementing and working with data-oriented programming. But as I mentioned, we're not done yet. So just earlier this month, again, Brian Getz, who I just mentioned, he put together a article that is kind of laying out the vision for more of these language features that are going to be coming in future releases. So we'll definitely check that out, because like working a little bit like data-oriented programming with records, it's not quite there yet from a usability perspective. Like if you want to update one field within a record, like you have to recreate that record, and that's a bit of a laborious process, especially if you have like a non-trivial record class where you have like, again, dozens of fields. And so like eventually like a lot of these language features would go towards making that easier to do. So definitely check that out. Very interesting. It can also give you an idea of where we are heading. All right, so getting past the language features, there's more to Java than just a language. We also have an API, and also we'll eventually be getting into the runtime stuff. So one nice thing that was added was sequence collections. And what sequence collections is that there was some very useful methods down in certain methods or certain interfaces within the collections hierarchy or the collections framework, and all we did was just kind of promote that. So if you wanted the ability to add an element to the start of a collection, now you can just call add first instead of having to add and then like put in where the position of it you want to be in. You can also just explicitly call add last. You also have the same with get first and get last. Also, if you wanted to reverse the order of collection, you can simply just do that by calling the reversed method. A lot of these same methods have been also promoted or added up into sequence map. Obviously, as it would make sense then for within a map context. So you have like get first entry, get last entry, pull first entry, get last entry, and so on. So I think seeing this visualized is very helpful. I say that because like oftentimes when we use a list, like how many people use array list kind of like as their default list whenever they're using like, I don't know, that's array list. I don't know, of course. So of course array list, because it is a list and a list extends off a sequence collection, it gets the benefit of all of those methods I just told you about. Similarly, though, or dissimilarly, a lot of times when I use a map, like I just kind of default to using a hash map. I'm like, oh yeah, just hash map because that's just what I saw in Stack Overflow 10 years ago, and I just never bothered to change. Well, hash map directly extends off of map, which would not benefit from the sequence map. And of course, that makes sense because it's hash, it's not actually any order to it. So if you wanted to take advantage of the sequence map features I just mentioned, you would need to use either something that extends off a sorted map, navigable map, or a linked hash map. So I just do that just because people might be like, hey, Billy said I could do like the add first or add last to my maps, and I don't see that. And it's probably because you're using something like a hash map that wouldn't benefit from these. Probably the biggest feature that was added, or most look forward to feature that was added in JDK 21 was virtual threads. And so what virtual threads are is adding a lightweight thread construct to improve the concurrency of the JDK. So kind of before this stuff, and you know, at some point, many of us probably had to try to take our hand and looking at reactive programming. I know I tried, for many examples, trying to put together some reactive programming POCs. I definitely remember doing that when Mary and I were working together, putting together some proof of concepts of that. At least for my part, speaking personally, like I always struggled with it. I'm like, okay, like I can do my really simple proof of concept example, but like I can't imagine really doing this in like any non-trivial example. You know, if I have thousands of requests coming in and then like one of them fails, like how do you trace that back? Or, you know, or okay, so like this is calling in, this promise is going off, and this promise comes back later. Like I struggled understanding it. I remember doing a presentation at a company that did a lot of reactive programming. I'm like, okay, maybe it's just me, maybe I'm dumb, but like even they said, like even though they've been doing reactive programming for like a decade, like they still struggle with it. I'm like, okay, it's not me, it's just difficult. So, but the purpose why I went off into that tangent is reactive programming was trying to solve an issue within Java of resource constraints, that creating a new thread is a somewhat expensive process within Java, and there's a somewhat limited number you can do. So like any program, anything you run in Java is running on a thread, from simple hello world to whatever actual complex applications you're working on and supporting at your jobs. But threads are a relatively scarce resource on the JVM. You know, so if you have gotten to the number of threads more than that JVM can kind of handle, then if you wanted to create a new thread, well, even if there was CPU available, that thread may have to wait until like some threads became available. And like also this is why we do things like thread pools, because we don't want to have to be constantly recreating new threads, which can take, you know, maybe about like a couple tenths of a second. It's like a couple of megabytes on heap. So we pool them. But the reality is that you can have a JVM and or a process, and oftentimes when the thread is executing, is that it's not always just doing a lot of work. A lot of times it's just spent sleeping. That my background is as a web application developer, and a lot of times I get a request comes in, and then we call out to the database to do some sort of work, to look the person up, and then we maybe call it to like a service to like say like, okay, update that service or update that order or something, and then we send a response back. So most of the time, that request is spent just sleeping, doing nothing, waiting for a response to come back from some external service. And so if we were to explode this out to the JVM level, potentially, is that what we could have is that we're kind of thread bound, but the CPU utilization could be actually still pretty low, because most of the time our threads aren't actually doing any sort of work. They're just waiting for a response back from some sort of external service. So virtual threads seeks to address this issue by splitting threads into two distinct parts. We have a platform thread, which is basically the equivalent to a pre-existing thread concept, you know, before JDK 21. And then we have a virtual thread, which exists only in memory and can then attach itself to a platform thread. And so these virtual threads, as they're created, they're put into a fork join work stealing pool, which is basically just a first in, first out pool, and that if it's not available to do any work with, it will just stay in there. So we have like all these virtual threads that we created, and then we have these platform threads that are ready to do work. And actually, I probably should update this graphic to be a bit more clear. But like, okay, so we add these platform threads or these virtual threads on, and that virtual thread, as it's working, it runs into some sort of blocking operation. It's calling out to a database, or it's calling out to a service or something. When it hits a blocking operation, the JDK can recognize, or the JVM can recognize, like, hey, this virtual thread is blocked, and can unpin it from that platform thread and put into the queue, and then put another virtual thread to run on that platform thread. Yes. Yep. Yeah. So the default behavior is first in, first out. I know there's been discussion on whether or not to allow users to create their own custom pooling thread, just to see, like, okay, like, there's some other priority of, like, oh, okay, something CPU bound or something that gets priority or whatever. Um, and I don't know if we've allowed that yet. Like, the problem with something like that is, like, it's really easy to blow your feet off with it, because so it's one of those where we're not sure. And it would be something that, if there was other implementations, like, it would be with, like, some sort of framework. It's like, oh, I'm using Spring Boot, or I'm using Quarkus, and Quarkus maybe has, like, their whatever other virtual thread handler or something like that. So great question. But yeah, so, like, these run into a blocking operation. So then we're like, okay, well, these things are blocked. We'll put them back into the queue, and then we'll get these other virtual threads, and we'll put them onto the platform threads to allow them to do their work. So the end result is that you're getting a much better utilization of your system resources. That you're not going to just have threads sitting there idling, blocking other things from working. They can be taken off and allow other things to work. Yes.
First question, you guys need to mix traditional threading with these virtual threads?
Kind of, sort of. So, like, a platform thread is basically like a traditional thread. So, like, let's just say you have, maybe, to your question of, like, okay, there's, like, some sort of CPU intensive work, and I want to assign that to, like, a platform thread and just have that work at it. Like, you could do something like that, because virtual threads and, like, CPU intensive work don't really work together that well, because you could just get into some thrashing of something like that. Yeah. Uh, I'm not sure you can actually. I don't know if you can do that. So, like, the number of platform threads available is based upon the number of CPU cores by default, and then you can also do some variation of that. Like, you can have, like, 8 platform, or you can have, like, 3 platform threads per CPU core or something like that. I can't remember if there's a way of you being able to reserve certain platform threads from being used for virtual threads. I just can't remember that offhand. So yeah. I don't know offhand. I can't remember if that is or isn't. So this is also part of the reason for some questions like that. That's kind of why I include that. I think in Jump 440. Yeah. Uh-huh. Yeah.
If how is it being handled when one of the threads is waiting longer than the other, but it's now in the backup queue. So the first one is now ready to process because that blocking operation is now done.
So yeah. So the way that works is that when this is blocked, it's going to be listening on the socket for when data comes back. And once data starts coming back to that socket that it's listening on, then it's eligible to be re-added and re-queued to be worked on again. So, like you said, like, so yeah, you have, like, 2 virtual threads. Virtual thread A gets dequeued first, and it's taking forever to, like, it's like the process it's waiting on. It's going to take a minute. Then you have virtual thread B running, and it hits something, and it only takes, like, a second. Once it gets, after it's been a second and it starts getting data back, it's like the JDK be like, okay, this virtual thread is ready to be run again, so it will be placed into queue to be reattached to a platform thread. Yeah, they're not. Yeah, they're not really. Yeah, they're in that queue, but they're not eligible to be taken out of that queue, I guess you could say. Yeah. Yep. Yep. But yeah, great question. And then, oh, I guess one last thing. So again, like, the difficulty with reactive programming is that it brings in like the two issues is that the programming model isn't something at least Java developers aren't used to. Like you're used to the way the program executes follows the way it's written, on in your source code file. And then also in debugging, like tracking back, like, okay, this promise failed. Like, how do I track back to like what spawned it off? Like, that's like the two major issues. Virtual Threads seeks to address that because, so here, like this light green virtual thread color is here. Like, even though it ran on two different platform threads, the stack and all that information stays with that platform thread. So that way, for debugging purposes, like you don't have, like it's very clear, like following the stack through it. And then also, you don't have to take on a different programming model to take advantage of this. Yes.
You have to look it up. So here we said in the JVM to actually define how many platform threads you want to go, but to actually process the thread through it.
Cool. Yeah, I couldn't quite remember offhand. I was like, probably, but I didn't want to say definitively, not knowing. Oh, okay, yeah.
What does the tooling look like for debugging virtual threads as opposed to the traditional platform threads? We're talking about like memory, garbage collection, stuff like that.
Tooling goes, they're really it it wouldn't really be any difference. The only way it could be different is because of potential scale. So, as I mentioned at the start of this, is that threads were traditionally a scarce resource within Java. So the number of threads you would potentially have would be hundreds, maybe 1,000 or something like that. With virtual threads, like a virtual thread at itself only is 4 kilobytes on the heap. And so you could potentially have millions of virtual threads. So the only way tooling would be affected by it is if it's trying to visualize the number of threads and you have a million threads, like the tooling may be like having difficulty potentially visualizing that kind of information. But otherwise, like if you had like 1,000 virtual threads versus like 1,000 normal platform threads or just threads before, like the tooling it would all look the same to you. The only difference is like there would be like a couple of additional identifiers of like a thread ID and then like a platform thread ID and a virtual thread ID. So, but yeah, as far as like all the tooling like that doesn't do much. And generally, as a developer, you wouldn't often be directly interacting with virtual threads. A lot of this would be happening at the framework level that like if you're using Spring Boot or Quarkus or MicroProfile or Helidon, like you would just like set some sort of argument saying like, hey, use virtual threads. And like if you're doing like a web application, like when you get a request come in, instead of that being attached to a normal thread, it would be attached to a virtual thread.
Well, if you were someone building frameworks, yes, what would you be looking at when it comes to? So this is already, feature coming to Java 26.
It got delivered in 21, so it's yeah. Yeah, no problem.
Okay, and so the tooling there for, I guess, looking at when, I guess you're looking at, let's say, millions of threads, virtual threads on, let's say, in the JVM, I guess has the way in which you, at least from what I'm familiar with when talking about these types of virtual machines that are do those processes of threads at once, there seems to be, I guess, a different tool, there seems to be more tooling involved in being able to go and have observability on that many,
Yeah.
objects, especially if you're doing this on a live environment rather than something that's in like a test environment. So is there something for, let's say, like production observability when it comes to these virtual threads and like what they're looking, what they're like what, especially in the sense of like memory and the architecture. Is there anything like that that you know of or understand there, or?
Really, now that most of my role revolves around often smaller scale stuff that like I haven't it's been a while now since I've actually like been debugging like an actual proper application running at scale in production. I mean there's so many different available options, like so like one of the things like we kind of provide is JDK mission control, which is like now an open source tooling for that. But then there's other tooling that kind of built upon that, like the like Datadog, App Dynamics, and all that stuff. And I, I haven't really worked with them at all that recently, but like I'm sure by now, like all of them have at least some level of support for handling the potential for millions of virtual threads, or at least a much larger scale of available threads. So yeah, but I mean that's ultimately on them to make sure they support that. So yep. All right, any other questions when it comes to virtual threads? Okay, great. Well, also feel free to ask questions at the end. One other thing. So, if you were following a lot of blog articles and what's happening, so shortly after we released virtual threads, Netflix, who started Netflix? Everyone, a few people for. So they released in their tech blog a blog article talking about how an issue they ran into virtual threads is that when it got in with if they ran into a blocked operation within a synchronized block, then that thread will remain pinned to that platform thread, and then that ran into an issue of resource consumption coming up where all the threads were being pinned and blocked and they couldn't do anything. So they kind of had to back out their virtual thread adoption. Anyways, in Java 24, we added a fix that resolved that issue. And so at least like I know like Netflix, like they're starting to adopt virtual threads now. So JDK 25 is probably what made it a bit more practical to use virtual threads. Yeah. Scope values. So there's thread local. In thread local, we put information like contextual information, like for security, we would put like authorization and authentication into like a thread local variable. Scope values kind of work in that same domain, except it is a immutable value. And kind of getting back to the issue I was talking about with virtual threads, that you have like a much higher potential scale available, is if there's like a value that you think could be shared among like hundreds or thousands of virtual threads, instead of putting that into thread local, which would copy that value into each virtual thread. So if you have hundreds of thousands of threads that are using that value, you're copying it hundreds of thousands of times. A scope value would just be a single immutable value that would be available within a specific scope that won't need to be copied. So there's potentially a lot less utilization of heap resources with that. The foreign function and memory API, as I mentioned earlier, my background is in web application development. I never did a whole lot when it came to native programming. But historically, we've had the Java native interface, and it's functional, but there's a lot of ways where you can when it comes to like to working with native memory that you could actually mess up your system or mess up your application. The foreign function, and also just the API wasn't written in a consistent way. The foreign function and memory API seeks to address that by having a much more consistent API interface when it comes to working with native libraries, in a much more consistent way of working with native memory. The Java native interface isn't going away. In fact, it's used within the JDK itself. But now, if you are doing native programming, I would recommend to be using a foreign function and memory API versus using JNI. We also developed a JExtract tool, which can read the headers for a native library and then automatically create the Java bindings to then work with that native library. Markdown is now supported in Javadoc. So if you needed to do formatting within your Javadoc, you would have to use HTML for that. HTML is obviously very verbose. So Markdown is a much easier to read for that. And so you would denote that by a triple backslash for that line, and then that line would be accepting of Markdown. Specifically, we're using the upmark formatting for that. Getting into Java 26, we're now offering HTTP3 support within the HTTP client. We're offering support, but HTTP2 remains the default. Part of the difficulty, HTTP3 supports a new transport protocol called QUIC, there's a number of ways, and that creates some difficulty because there's not a way of knowing what transport protocol you're going to use before you make a call. Anyways, if you check out the JEP 517, they go through 4 different strategies you can use on potentially handling, like, do you use HTTP2 here or HTTP3, and so on. Finally, kind of getting into runtime features and tools. There's the simple web server. So this again kind of gets back to our educational pursuits, where oftentimes early on when learning a programming language, like within like the first month or first couple of weeks, a task is like, oh, to serve some stuff up on a web page or something like that. And if a person was learning Java, well, they would either have to go out and download like Tomcat, or they would use like Node or something like that. And not both of those have their issues. Now we offer the simple JWeb server, which is built right within the JDK. You can invoke it with JWeb server. Actually, sometimes I actually run this presentation using JWeb server, and it just serves up the files within that directory. Just don't use it in production because there's no security around it. Generational ZDC. So we introduced the Z garbage collector, which is effectively a pauseless garbage collector, which is really good, particularly like in a web application setting where latency, you want to reduce that as much as possible. So when we first introduced it, it was single generational. Now it's multi-generational, which is a whole discussion around garbage collectors, but all the same, now the generational ZDC is the only option starting with JDK 24. G1, that's the default garbage collector. So if you're not explicitly declaring a garbage collector within when you're starting up your JVM, then you're almost certainly using the G1 garbage collector. And so we're continuing to support it going now and into the future. We also now, so back in JDK 11, we added the ability with the Java launcher to automatically compile and execute a source code file. Because instead of having to do Java C on a source code file and then calling Java to execute, and now you can just do Java in a source file, it can automatically compile and execute. That was initially only on a single source file application. Now you can do it for a multi-file application. So here I have like my main class, and within my main class, I'm calling I reference the person service and the person class, and then I'm importing it by model and service. So as long as the file directory matches my package structure, which it should for when you're writing Java applications, then the Java launcher can automatically find, compile, and then launch those Java source files. One of the newer things that are being integrated into the JDK is Project Leiden, and this is ahead of time computation. So when you're starting up the JVM, compared to other things like a native compiled language like C++, or to like just a simple interpreted language like JavaScript, the startup time is somewhat substantial because you're building up the whole JVM, you're loading all these classes, and then once you have them all loaded, to hit peak performance, the JVM can review what parts of your application are being used and maybe how they can be optimized, and then you can recompile that code, optimize it, and then your applications run faster. So when you ever start a JVM, like all this stuff happens, but then when you kill your JVM, it's just all thrown away, and then you have to do it all over again the next time you start up a JVM. So what if you could actually save that work? That's what Project Leiden is. And so instead of just throwing all that work away, you would review that, you would have a training run, you would put that information into a cache, and then on subsequent runs of the application, it can load from that cache, and that can improve the startup and then the warm-up performance of your applications. So we started that with JDK 24 with ahead of time class loading and linking. Then in JDK 25, we made it a little bit more simple if you wanted to do like a 2-step process for all this, as well as offering method profiling, where that is, we'll say, okay, what methods are being the most used, and then which should then be recompiled. All the same, very interesting feature. So you can run a training run with the AOT cache output, and then you go through your training run. You want your training run to match what your production run would look like. You kill it, and then on your subsequent runs, you reference that cache you just created, and your startup and warm up performance should be a bit better. It's been a minute since I last tested this, but like I think the benefits I was seeing on a simple Spring Boot application was like maybe a 30% reduction in startup performance, and like it's harder to quantify percentage improvement in warm up, but like a noticeable improvement in warm up performance as well. So, um, yeah, very nice. There's also compact object headers. So the headers for reference types, like they're referencing, like, hey, where is it on the physical memory? Where is it in heap space? And what's the liveliness of this object? And all these different things. For smaller objects, the size of the header could actually take up a significant portion of what its heap spot of its size on the heap of the Java memory heap. Um, and also, a lot of objects are pretty small in size. So basically, what this is trying to solve is saying instead of necessarily taking up, I think it's like 64 kilobytes, it can be 32 kilobytes of heap size, or 32 bits. Yeah, sorry, 64 bits or 32 bits. So like it's handling it from 64 bits to 32 bits for your heap headers. At least what I found in my personal testing, it did reduce the heap by about 10%, but I also was finding a throughput regression of 10%, which wasn't really expected. So I know the JDK engineers are actively looking in to see how that throughput regression can be resolved, so that way in future JDK versions there shouldn't be any throughput reduction for using compact object headers. Also reduced latency just because you're not having to do as many GC collections. Lastly, on runtime updates, is there are some couple updates to JDK Flight Recorder. Just a little bit of an earlier question when it comes to tooling and observability into the JDK. One tool that's often overlooked that's built directly in is the JDK Flight Recorder. Um, this one is kind of back end, so you wouldn't really work with it. But the method timing and tracing, kind of as the name says, is it allows you to say like, hey, how long is it taking this method to execute? Our tracing is what are the code paths that are calling this method. One of the nice things using the JCMD or J command tool is you can, like, let's just say there's some sort of issue happening with your application in production, like some random, like every 2 or 3 weeks, like you just get like a real weird random slowdown in your application and you just can't figure out why. You could actually enable method timing and tracing on a live running application to potentially say like, okay, wait, why is this method, like we think it's like these three methods. Like you can say like, let's turn on method timing on these three methods to see maybe which ones are running slow, or method tracing to see like, okay, we think, this is the call order for these methods, but maybe something else is calling this method that's maybe causing the slowdown. But it's nice that you're able to enable this stuff actually on a live running application to potentially get that diagnostic information as an issue is occurring. So another very nice feature that was added. Definitely check out the JEP, and we also have some like examples also out there on how to do this stuff on a live running application. So with us, part of good stewardship isn't always just adding stuff, but also knowing when to prune. So there are some deprecation and removals that have stuff that has been removed. For 32-bit x86, we're no longer supporting it as of JDK 25 or 24. So yeah, 24 is when we said Linux was going to be deprecated for removal. I think it was actively removed then in 25. So all the same, we're no longer supporting 32-bit x86. We also did permanently disable the security manager. And forgot, I need to include that. But the reason why we did this is that we're getting rid of the applet API, and fundamentally the only reason you would really need the security manager is for the applet API, because the security manager is saying like, hey, if these particular classes or these packages or something, like they would have like maybe this level of privilege, like okay, like the packages and classes I wrote, that can actually like write to the operating system, but like anything else added, that shouldn't be given that opportunity. That would be where the security manager could be useful, but we're getting rid of the applet API, and the applets have not been used for a long time anyways. Um, Whenever we bring in third-party code, we're doing it at build time, and we can just use static analysis to do whatever security checking to make sure of like there's not any sort of security vulnerabilities within that library that we're bringing in. Another thing is, as I'm sure maybe most developers are aware, but you probably may ran into it, it's like final doesn't really mean final right now in the JVM or in the JDK. You can use reflection to go in and change the value of a final field, which obviously defeats the purpose of it being final. So we're working towards to where we're going to prevent that by default. And so what we're initially going to do is whenever this happens within your application, starting in JDK 26, we'll send out a warning message saying like, hey, this final field was modified, just to let you know that that's happening. Eventually, the goal would be to prevent that behavior by default. Now, you could still re-enable it if you needed that behavior for some reason. But what we're trying to do is do this thing called integrity by default, to where I have a formatting issue there. Sorry about that. To where the JVM that works and behaves in a way that's much more consistent with a user's expectations, and not to actually introduce any kind of bugs or unusual behavior that's not really explicitly asked by the user. So prepare to make final main final is one of those. And here's a couple of other changes that we're also doing that is towards that goal. But if you go and check out this JEP, this kind of explains the overall goal of what is meant by integrity by default. All right, so getting into the beyond, and I'll kind of get through this because we're kind of running a little bit long. So structured concurrency. Structured concurrency is a really nice feature for handling concurrent tasks. The nice part is, so here we're setting up a task scope, and it allows there to be first a relationship between a parent task and then the subtasks that respond below it. So that way, if an issue happens with that subtask, you can link it with like the parent task that called it, which currently isn't easily possible. Um, and then also you can also reason about all these tasks together, to where it's like, okay, if one task succeeds, then maybe you cancel everything else because you just need one result. Or if one fails, maybe everything should fail with it because you need them all to succeed. There's a lot of other options available, and you can also implement your own behavior. So that's kind of what structured concurrency is seeking to improve upon. Primitive type patterns. It's just allowing primitive values to be referenced within pattern matching. So like in this example, like I have like, an auto box integer of 0, 1, and 2, but then I'm explicitly referencing the int primitive type all within the same pattern. Lazy constants. What this allows is for a final value to be set later than right when it's initially initialized. And like a common example of that is with like with loggers. Like sometimes you don't necessarily need to set that right when a class is initialized. You can wait until maybe the first call to an initial or to a logger happens before it needs to be initialized. But basically what this is that once it's set, then it can't be changed. So that way the JVM can treat that field as final, even though it's not necessarily declared final. The vector API, that's going to remain in incubator status until Valhalla starts delivering, which might actually start happening here somewhat soon, maybe JDK 28, if we've all been good Java developers and Santa, puts us on the nice list. All right, so that's it for follow-up links. If you're on JDK 17 and you're considering upgrading to JDK 21, the Java DevRel team that I'm on, we put together a playlist that covers all the considerations when upgrading from 17 to 21. We did the same thing from 21 to 25. And here's also a lot of the links I referenced also in this article. And yeah, and again, if you want to know more about Java and the future for it. Like I said, I'll be at Java 1 presenting and everything like that. So come join me there. And you can also ask the architects themselves as well a bunch of questions. So that's also a lot of fun. But with that said, yeah, any more questions then? Yes. Uh, sorry. So my thoughts on running Java in containers in Kubernetes. Yeah, I mean, yeah, we've been supporting it for a long time, just because exactly what you said. Running applications in containers has become the default for now, and yeah, we support it. We continue to improve our support for it, but yeah, we anymore kind of expect that to be the default for Java applications to be running in containers. Yep. Yes.
Java, guys, any chance that the NCD ideas will be introduced into the
Any of the what ideas?
NCD?
MCP, Microsoft. I mean, so one of the things.
Model context.
Oh, model context protocol.
Yeah,
Gotcha, for the AI stuff. Yeah, so we're continuing to do a lot. So I sometimes avoid AI stuff, but so some of those APIs are kind of implemented at the library level. So I don't know if we're going to necessarily bring some of those concepts directly into the JDK, because we're more about building out the basic tools to build that from. That said, part of our AI strategy is things like the foreign function and memory API to give you better working with native libraries. Then there's also things like Project Valhalla, where Project Valhalla is about allowing you to have reference types without identity to them. So that can also allow for better memory density. And then lastly, we also have Project Babylon, which will allow the JVM to make direct native use of GPU resources as well. So like something like Model Context Protocol, we probably wouldn't directly add to the JDK, but there are other ways that we're working to support AI development. Yep. Any other questions?
Yeah.
Great. Well,
Anyone?
thank you very much.
Okay,
Feel free
cool.
again to reach out to me at billy.corando at Oracle, and also again a link to this presentation. Thank you.
Thank you.
Thank you for all the questions.
Thank you, Billy. So now we'll get into the next phase, which is just a couple minutes for the
You wanna
raffle.
connect?
Yeah, yeah. Maybe I'll just plug this in because it's the wheel of names.
Yeah.
Yeah.
Oh.
Thank you. Okay, actually, let me do this one thing. I'm also sorry.
We want full transparency, right?
Yeah, that's right. Okay, get this. Okay. Okay. Whoops, sorry. Where did it go? I got way too many things right now.
I know. I hate when I do that. Just like
Yeah, I know.
too many.
Anyway, okay, here we go. Okay, so we have Shadi and Sanjay, Hari, and Ike. Is that right? Correct, right? Ike, did I say your name? Okay, so anybody else wants to enter into the raffle? Of course, we have the rule of like 9 months, the cooling off period. So if I don't hear of anybody, or maybe on the live stream, and Che, is there anybody on the live stream wants to enter? Okay, all right, so we're gonna do two. So let me make sure the sound is turned on. Oh, here we go. Okay. Thanks. Maximize this too. Great. Okay, here? Okay, here? Shadi? Yeah, who's Shadi? Yeah, okay, great. Yeah, so you received that in the mail. And then
Man, you got a Duke plushie and
wow.
wow, this is very good. You're
Yeah.
cleaning up.
That's right. Yeah, you deserve it. Okay, one more.
Oh.
Let's see who.
Oh.
Jay. Okay, I'll send that to you. Thank you. Thank you all for attending, and congrats to the two who won the raffles tonight. And thank you again to Billy.
Thank you, Mary.
It's really fun to have you. Everybody,
Yeah, absolutely.
I said you are the crowd favorite. You know, everybody, before he came, everybody was like on our Discord channel. If you're there, everybody is like teasing.
Yeah.
Teasing Billy. It's so funny. So yeah, so really happy to have Billy here, and thank you for venturing through the cold.
It is very chilly.
Yeah,
so.
I know. How cold was it in Kansas City?
It was about like this earlier in the week, but it has like warmed up to like just normal freezing,
Oh,
not
okay, yeah, not
not
like this.
not single degree.
That's right. So great, yeah, and thank you all for coming out in the cold.
Thank you,
and
everyone.
Thank you, and there are some more pizzas too, so feel free to take more food and chat a bit too before you leave for tonight. So thank you again, and I hope to see you again too. So we haven't planned the next one, but we should have something either later in February or for sure, I think in March we'll have something. So thank you. Yeah. All right.
And if you're here for Jose, just tell him that you like me more. That would mean a lot. To be like,
Yeah.
bring Billy back.
Yeah.